Does the data set below appear to be logistic in nature? This could be data taken from the real world. It's bivariate data because each coordinate pair includes both an x and a y that are somehow related. For example, the x could be time, as in days, and the y could be population of some kind, perhaps the spread of a virus, for example. That's a big thing that people are interested in modeling these days, especially due to the viral outbreaks we've had recently. So let's try to plot the data using statistical software. There's an online app that's really good for this. We can also use the TI-84 calculator to make a plot of the data. But since I'm on my computer here, I'll bring up the app desmos.com. And what it'll let us do is create what's called a scatter plot. That's just a plotting of x and y coordinate pairs as dots. So just go to desmos.com. You'll want to add a table here in the upper left by clicking the plus. That's going to give you x1 and y1, and these are columns where we can put our data. So let's type in the x's. Okay. Now I want to do the y's that go with them. All right, let's check out what we did. Program is going to make a scatter plot, and we can actually use this wrench tool here to change the view. So let's display just up to perhaps an x of 20. Yeah, that looks good there. Okay, now it's time to make a regression model. This would be a mathematical function that is the statistically best fit function. And there's many possibilities. We could do linear regression, we could do quadratic regression, exponential regression. In this case, we're going to want to do logistic regression. That's going to be the best fit mathematical model here. But anyway, to add a regression line or curve, you go down to the box number 2, and you can't just type y here because in our table it had designated y as y with a subscript 1. We have to type that when we enter our mathematical model too. And another thing about this application is you can't use equals for a regression line. You have to actually use the shift and then the tilde in the upper left. It's a squiggle. That'll allow us to make a regression curve. So let's say at first we just wanted to do linear regression. How would we do it? Well, just type in mx1 plus b. You got to leave your constants as variables, well, as letters, and then the program will actually tell you what the best fit statistical numbers would be that would fit this data the best. As you can see, linear is a decent approach. It certainly is true that as x increases, y is increasing as well. But we could do even better if we choose a different type of curve. So let's try exponential. If we were doing exponential, it would be ab to the x. And, you know, that's not quite right here because it's not just exponential growth, it's logistic growth. So let's put in the general form of the logistic formula. We want L over 1 plus a b to the negative x is one way to write it. And as you can see here, it gives us the statistical best fit L, B, and A in that case. But in the problem that we were given, it actually wanted the logistic function in a different form. Instead of using B, it actually wants e to the kx. And as you can see, the limit hasn't changed, and neither did the a, but this time we'll be given a k constant instead of a b constant. All right, so the data turned out to be very, very linear, logistic, I mean, and if you look close, you can see that not every data point is exactly on the curve, but that's expected because we're taking data from the real world and trying to fit it to a mathematical curve as best we can. So our L was 100.2. Okay, we've got an A of 23.3. And a K of 0.495. At this point, we could substitute in our constants. And there we go. There's our best fit function. Now what could we use this for? We could use it to make predictions about the future, perhaps. I'll try f of 20. So see, 20 wasn't an x that was given in the data. So we could find a prediction for what the value would be at 20. Now in statistics, this would be called an extrapolation because 20 is outside of the x values that we had actually collected. It would be interpolation if the x value we were predicting was within the range of the data that was collected. And so interpolation is supposed to be better prediction than extrapolation, but it still has value nonetheless. All right, let's try it here. I get a output of 100.09. So it's close to the limit of 100.21, which is expected.